Day 172 of doing a LeetCode problem every day until I get a job. Alright, y'all, we're back again another day, another LeetCode problem, but y'all already knew that. Why? Because we're here every day doing a LeetCode problem until we accomplish our goals, whatever they may be, y'all. Whether you're trying to get that new job, whether you're trying to get that app on the App Store, or whether you just like coding as a hobby and you do it for fun and you're not really you don't really have any goals for it. We're still going to be here every day and we're going to be here learning together, encouraging each other to stay disciplined and stay consistent, because even if you don't have any goals right now, if you stay consistent, you'll be able to set goals for yourself in the future, because you'll have the skills that you need to accomplish those goals, and they will be specialized skills that everybody doesn't have. So that's why it's important to practice, and make sure you're at least programming and learning some LeetCode every day. Now, before we get started today, y'all, don't forget, bring your mouse right over here and click that subscribe button for me, y'all. And then after you click that subscribe button, go ahead and smash that like button for me, y'all. And then after you smash that like button, I'm calling all of my bankers. I repeat, all of my bankers to the comment section right now. I need y'all to drop 2 bank emojis in the comment section so we can run up this engagement and we can push this content out to a broader audience, y'all. As Swift community members, it's up to us to help the community to grow, and one way we could do that is to share this Swift content with as many people as we can find that will watch it, y'all. So y'all support is appreciated for that. Now, let's see what the question says. And today we have question number 914, X of a kind in a deck of cards. The difficulty level is easy, so you already know we're going to keep the solution as simple and easy to understand as well. So let's see what the question says. It says you are given an integer array deck where deck of I represents the number written on the ith card. Partition the cards into one or more groups such that each group has exactly X cards where X is greater than 1, and all of the cards in one group have the same integer written on them. Return true if such partition is possible, or false otherwise. So let's break that down so we can see what they're talking about. In example 1, we have input deck equals an array of integers 1, 2, 3, 4, 4, 3, 2, and 1. The output is true. The explanation says the possible partitions are 1 and 1, 2 twos, 2 threes. Let's start over. The possible partitions are, you can have a group of 2 1s, you can have a group of 2 2s, you can have a group of 2 3s, and you can have a group of 2 4s. The output is true because these partitions right here fit the requirements, right? So each group has to have exactly X cards where X is greater than 1. So in this example, in example 1, X equals 2. All of these have 2 elements in it. All of these groups, there's 2 elements. There's 2 1s, 2 2s, 2 3s, and 2 4s. Then the next requirement is all of the cards in one group have the same integer written on them. Once again, there's 2 1s, that's the same integers. There's 2 2s, those are the same integers. There's 2 3s, those are the same integers. And there's 2 4s, those are the same integers. That's why the output is true. So let's look at example 2 where the output is false, and it might be a little bit more tricky, right? So in example 2, we have input deck equals an array of integers 1, 1, 1, 2, 2, 2, and 3, and 3. The output is false. Explanation says no possible partition. So if you look here, the first requirement says each group has exactly X cards. So if you look, we have 3 1s, we have 3 2s, and we have 3 3s. Because all of the cards in one group have to have the same integer, we cannot make each group have exactly X cards, right? Because say if X equals 3, then we'll have 3 1s and we'll have 3 2s. But we only have 2 3s, so X, that would not be X. X can't be 2 and 3 at the same time. So that would not work. Or say X equals 2. So we have 2 3s, but then we have 3 2s and 3 1s, which means X is not going to be the same for all groups, every group, which is why the output is false, because there's no possible way to partition that and with the requirements that they've given us. And so we will return false. Now, now that we understand the question, let's get into the fun part, the actual code. And it's not even that difficult. It's not that much code, y'all. It's only about 3 or 4 lines. So let's get into it. The first thing we're going to do is we're going to create our helper function. We're going to say func GCD. We're going to open up the parentheses. We're going to say underscore A colon integer. Then we're going to say comma, excuse me, that should be a comma, underscore B colon integer again. Then we're going to come out here and it's going to return an integer. Then we're going to come right here, we're going to say B is equal to 0. Now with this right here, this is a boolean, so this is going to return true or false. So it's going to say if B does equal 0, it's going to return true. If B does not equal 0, then it's going to return false, right? So then we're going to come over here, we're going to say question mark right here, and we are going to say A. So B does equal 0 and it's true, we're going to return A. If it doesn't, we're going to say colon, we're going to say GCD, we're going to use a little bit of recursion, we're going to say GCD, comma, GCD parentheses, B, comma, A, mod, B. Just like that. Then we're going to come over here, up here, we're going to declare constant, we're going to say let counts equal set. So we're going to create a set of dictionaries. So we're going to say set, open up the parentheses, dictionary. Then we're going to say open up more parentheses. We're going to say grouping colon deck. Then we're going to come outside of those parentheses and we are going to say, we're going to open up some brackets. We're going to say $0. This $0 is going to create, it's going to represent each set that we are creating. Then right over here, we're going to say dot map, and we are going to say open up some more brackets. We're going to say $0 dot value, it's going to represent this right here is going to represent each dictionary that we're creating. Then this right here is going to go map out each dictionary's value dot count. So we're going to get the count of each dictionary's value. Then we're going to come down here and we are going to say, or we're going to return counts, open up the square bracket, counts again, dot index, open up the parentheses, after colon, counts, start index. Then we're going to say, come outside of that. We're going to, outside of those parentheses, but still inside the square brackets, we're going to say dot, dot, dot. Then we're going to come outside of the square brackets. We're going to say dot, reduce, open up the parentheses, counts, dot first. It's an optional, so we're going to say exclamation point. Then we're going to come outside of that. This is where we're going to call our helper function. We're going to open up the bracket, say GCD parentheses, $0, comma, $1. Then we're going to come outside of those brackets, say greater than 1. And that should be all she wrote, y'all. Let's run it. Make sure it runs how it's supposed to. Ooh, what does it say? Have grouping. So it should be grouping, not groupling. No, let's see. What is, ooh, look at that. So let's submit it now and see what it's looking like after we submit it. Let's see. Okay, 4 milliseconds beats 84.62% of users with Swift, y'all. That is not too bad. Not too bad at all. And I hope y'all learned something today, and I hope to see y'all tomorrow for another day, another LeetCode problem. See y'all then.